Hi, my name is Brian Reed, and I'm the Chief Mobility Officer at NowSecure. And with me today is my partner, Tony Ramirez, also of NowSecure. And we're going to talk about how the latest MASVS and MSTG specs make the best mobile pen testing cocktails. Now, a little story about this session. We were originally expecting to be at the end of the day, so we thought we'd make it fun with drinks at the end of the day. Now, it's a virtual conference, but we encourage you to grab your favorite drink in the background and drink while we talk and teach you about MASVS and MSTG. So a bit about me. I'm Chief Mobility Officer here at NowSecure. I've been here for about 15 years. I was here at the birth of modern mobile security around BlackBerry and have been working with mobile technology companies and mobile customers for decades. My favorite drink today is a Whistle Pig Old Fashioned. And again, as I said earlier, we encourage to bring yours along for this journey. Now, a little bit about our background here. So we've been doing mobile pen testing and mobile forensics for over a decade and worked with some of the largest mobile companies. Odds are pretty good you've used one or more mobile applications that have been secured using our best practices, our technology. Our security research team is well-renowned. They created tools like Frida and Radare, you see at the bottom here, that are very frequently used by advanced mobile pen testers and advanced mobile researchers. And we're excited to be one of the founding enablers and creators of the OWASP mobile project as well. And so as part of that journey, I'm going to start us out today a little bit looking at what's been happening at mobile now over the last couple of years since I presented last time. It's really amazing to see things like augmented reality, where you can overlap mind map on top of a photo. Digital payments are obviously there. I happen to have a Tesla and I can summon it to me. And we just saw the announcements with Apple and BMW on car keys. I have an Aura health ring. I use that to track and monitor my health. And many more innovations have occurred. And so as we think about it, the reality today is that 70% of all digital traffic and all digital time spent on the internet is actually spent in mobile. And so many security analysts, security researchers that we work with come from the web world and have started in the web world and may not have realized that mobile actually dominates usage now. And so everybody wants a great, high secure, easy to use application. But the reality is when you benchmark mobile data, and we benchmark millions of apps in the Apple App Store and Google Play to give us these statistics, you find that about 85% of those apps fail one or more of the OWASP top 10. 70% of them leak GDPR. And for most organizations, mobile security testing is a very brittle experience. And for most organizations, it's really hard to find mobile security analysts. For you and your career, it's a great opportunity to make some money by growing skills around mobile. Now, if we carve up the OWASP top 10, what you'll actually find is M2 and M3 tend to be the highest failures. So 50% of the mobile apps we've tested have insecure data storage and 48% have insecure communication. And nearly half have extraneous functionality that's actually exploitable, M9, which is also a bad thing. And so what we realized on this journey is that the testing capabilities that organizations have, from the skills to the tooling, has largely been lacking as people have moved from web to mobile. So I want to just spend a minute here talking about web to mobile and an attack surface, and I'm going to hand it over to Tony. So when we think about web, it's inherently secure to a degree from the perspective that 98% of the code is behind a hard-coded perimeter and really heavily defended. Now, that doesn't mean there aren't vulnerabilities, and that doesn't mean that cross-site scripting doesn't happen all the time, but that's an architectural design paradigm. Versus mobile, where the majority of the code actually lives on a mobile app that lives on a mobile device. That device is not hardened. It's in the wild. It's easy to reverse, as we're going to show you today. And so the architectural differences create a broader attack surface that is easier to attack, frankly, than a website. And that means mobile application security testing skills and tooling have to advance pretty substantially in order to understand that difference. And so that starts with understanding the mobile attack surface. And we're going to learn more about this in our 10 best practices. And the mobile attack surface spans not just code functionality, which is traditionally what we look at from a web security testing perspective. It actually spans data at rest, data in motion, and the API backends. And so if you think about testing a mobile app, it's already running in a browser. That browser is inherently secure. And hopefully you're using SSL, so the network connection is inherently secure. And hopefully it's connecting to secure backends. But when you have a mobile app, it's running on the wild on this device. And that means a developer has to understand how to securely store data for data at rest. They have to understand how to write the code to secure the network connections and manage things like certificates and hostname validation and a whole lot of skill set they typically don't have. And so let's take a quick look at the anatomy of a mobile attack, and then let's look at how to prevent it. So what the bad guys do, and what you can do as a security researcher, is you can surveil the mobile app. So you get the binary, whether you're downloading it from an app store or somewhere else in the world. Download it and reverse it. Grab our favorite tool, Radari and Frida, and tear it apart. There's lots of other tools you can do it as well. And then a security analyst will interactively manipulate the inputs and the outputs to figure out what it does. And along the way, they almost always, like 99% of the time, find PII that they can harvest on the device or over the network. And they also get to map all the endpoints by running the application and seeing where it goes. It's not uncommon, like 48% of applications will find a network issue. They discover a cert validation failure. And guess what? That means they can now create a phishing endpoint attack on the application. We've seen it many times. We often build them as POCs to help developers understand what they're doing wrong. Now they can harvest credentials, they can redirect payment, all kinds of bad things, right? And I'm not here to say the sky is falling. I'm really here to introduce Tony. And Tony's going to walk you through a more detailed analysis of understanding what the MASVS is and how you can use it in your organization. All right, and I'm out on part one. Oh, crud. I forgot he had an intro slide for him. All right. I'm going to go ahead and do 30 seconds on this, and hopefully you can slam it on the out. Actually, let's do this. Let's go back because no. Can you find that cut? Are you cutting it for me? Okay. I'll do the last two. Yeah, I'm just going to do this one and this one. Let me just go look. Yeah, there you go. I was anticipating Tony had added that because he thought it hooked it. So anyway, I'm going to go do the understand the anatomy of mobile attacks. So we'll kill the other one. We'll do this. I'll do 2 slides. We're done in about 60 seconds. All right. Here we go. 5, 4, 3. So let's take a look at the anatomy of an attack to really gain the better understanding, and then we'll dig in the MASVS to figure out how to test this. And so what the bad guys will do, or what a good security researcher will do, is surveil the mobile app, download it from the app stores, and reverse it. It's easy to reverse with R2 Frida, hook it, and you can pretty quickly figure out what's going on. Even an Apple app that might have DRM really can be cracked. And then they'll interactively manipulate it, and they're going to start to discover something. And what we find is about 99% of apps leak some kind of personal data. Maybe it's just GPS or advertiser ID, but maybe it's something else scary. And in this interaction, what they're going to discover is they can map all the API backend endpoints. So now they have intelligence on your IP, some of your PII, and how it's connecting to the back end. And more often than not, about 50% of the time, they'll discover there's a networking issue that they can then use as an attack surface and exploit. And so they might redirect to a phishing endpoint, and now they can basically harvest credentials or payment or some other kind of information. We've seen this happen for real in the wild. Our security analysts and researchers often use this with developers to teach them how this happens. It leads to bad things like account takeover and all the rest. So I'm not here to say the sky is falling. I'm saying that the anatomy of mobile attack and what's actually exploitable on a mobile application is bigger, wider, and more complex than web. And that's why the MAS and MSTG exist. And that's why we're talking to you today. And so, if we think about every application is created different, then testing each app is like mixing your own cocktail. So we're going to have some fun with drinks and mixing drinks and talking about the MASVS and the MSTG as we go through Tony's top 10.
Hey folks, I'm Tony Ramirez, Senior Application Security Analyst at NowSecure. I've been at NowSecure for a little over 4 years now, and I've been in the mobile application security space for about 6 years now. I've been a pen tester here, application security trainer, and I also help write best practices for NowSecure's customers, along with creating a training on Cybrary on mobile application security. So if you're new to mobile application security, there's a free training out there on Cybrary called Mobile Security 101. Check it out. My favorite drink is Sazerac. I don't know, I like it. It's kind of licoricey. So we're going through our 10 best practices. These are the things I would tell you if I was like the mobile security bartender and kind of telling you, hey, these are 10 high-level tips to be aware of, 10 things to kind of take away and kind of build on top of. And we're going to kind of scale things up as we go, because I know not all of you are beginners and a lot of you are. So, I want to be able to give you all a little bit of context and where to start and where to go. And I think really to get started, you have to really get started in the right way. So for those of you who are attending this session, you're likely aware that it's really focused around MASVS and MSTG. If you're not, MASVS is the Mobile Application Security Verification Standard. Say that 5 times fast. MSTG is the Mobile Security Testing Guide. So MASVS is kind of like a requirements guideline, a great way if you're starting off in building apps, or you already have an app security program, or just have a bunch of developers who want to know, hey, what are the things I should be aware of when building apps? It's just a great guide for figuring those things out and kind of setting some standards. And with standards, you need to have test cases and methodologies to go against those standards. And that's what the MSTG is. The MSTG is a cross-platform kind of thing for testing apps. You know, you have iOS, you have Android, and you even have hybrid framework test cases that are really useful. Many of you are likely already aware that there is a mobile security project on the OWASP website. It's called the OWASP Mobile Security Project. But you might also be aware of the more popular project, the OWASP Mobile Top 10. It's that list of, top 10 issues that, you might confront when you're testing apps or developing them. And it's good to be aware of because, they're telling you what order of prevalence that they've been in. And that's been around for a little over 5 years now. On the flip of that, you have these other 2 projects, the MASVS and the MSTG. And on top of those 2, you have the Mobile Security Testing Checklist, which really just implements MASVS and MSTG and kind of to a checklist that's useful if you're, building out these programs and trying to pen test apps and going down the line, trying to fill out the checklist. So on top of getting started, there's a whole other aspect to what you're doing. For me, pen testing really comes down to using all your senses. It sounds kind of silly, but hear me out. In mobile, you really need to have different types of tools, different types of cases where not one tool is going to work for every scenario, and you want to be able to use all your senses. You want to be able to use jailbroken and rooted devices because those really open the door to use a lot of open source tools, to use a lot of tools that require the ability to do certain actions on the device that really aren't built in. On top of that, open source tools really are powerful because they are really what you'll be relying on to do a lot of that type of testing. Eventually, you will probably look to automation to figure out a lot of these problems, but ultimately, a lot of high-risk scenarios are going to require things to be done manual. And manual analysis is always going to be a part of security testing. The other part of this, of course, is that you actually have to know what apps you have. And this might sound silly, but it's okay to not know how many apps you have. But as time goes on, you'll want to ask yourself, oh, is that one of our apps or is that one of the public apps that we use? Oh, do I care about the public apps that we're using? Or, hey, is this developer developing an app just to be used by him, or is it being used by her and all these other people, or all these other folks who are a necessary part of the team? And you'll eventually want to figure out how you want to approach those. And we'll have some solutions for that later on down the line. The other end of mobile application security testing, I think, that's really important when starting out is learning the attack surface. A lot of you are probably coming from the web application world, and you're probably really well adversed with the web security issues, how web is structured, and maybe you're not, but there are really some big technical hurdles you're going to have to come over when transitioning to mobile. And most of it has to go along with that, the fact that you're really running source code on a remote device. You're dealing with a lot of aspects that you really can't trust. And a lot of the issues in web do translate over to mobile, but you kind of have to be a different type of practitioner, and you kind of have to take a different point of view because the attack surface is really complex. And what's great is if you're using MASVS, you're covered because MASVS really does touch on a lot of these things that really, for a lot of security professionals, is the full scope of mobile. Not only are we talking about the things that are happening on the device, the things that are being sent from the device, the platform itself, but also the design aspects and the other things that come into place. So ultimately, you'll be able to kind of figure out what's important, what's not important, and in most cases, you'll be able to figure out what your app's attack surface is because all apps are a little bit different. And all apps have a little bit of a different attack surface. And a perfect example is having a feature like in-app browsers or a web view. This brings us to the first change in the MASVS spec. So for those of you who are very familiar with it and have been following it, you may already know some of these changes. For those of you who haven't looked at it in maybe a year, this is great because this is an opportunity for you to find out what are some of the new things in MASVS. And some of the new stuff around platform interactions are better web view practices. And a lot of those web view issues that I see relate to how that web view content is stored on the device, how those web view content best practices really come down to where you're loading that content from, how you're loading it, and how it ends up on the device eventually. So being able to verify that type of storage really is kind of a forensics challenge, a data at rest challenge, and really requires jailbroken and rooted devices. Another one that was added this past year was third-party keyboards. Whether you want to support them or not, sometimes third-party keyboards can be extraneous because they can represent another attack vector for an application if you accept any keyboard. On top of that, overlay detection is a huge thing for a lot of applications, especially in the financial space. So being able to leverage the Android platform features that are in 10 and 11 are really going to be important to really confronting those attacks like cloak and dagger. Number 3 is knowing where your data is when it is. It's a little convoluted, it sounds a little weird, but we'll get there. When I'm talking about sensitive data on a device, I'm really talking about what's being stored on the device, how it's being stored onto the device, and who has access to it. So there's a number of mechanisms, both in Android and iOS, that allow users, other apps, or even other places to access the data on your device. And it's important to be aware of what those things might be. Not only that, but when we actually start looking at the mobile top 10, you're going to see data at rest or sensitive data issues as number 2. That's M2. In my opinion, it might even be M1 because it's something I see so often. Data storage testing is actually kind of one of my favorite areas. You really do need a jailbroken and rooted device because if you really want to see everything that's stored on the device, you need to get that level of access, that level of privilege that you need to really kind of compromise the device. And in some cases, you don't. So being aware of how that data is stored and how it can be shared is really a necessary part to understanding how that data might be used by somebody who's malicious or somebody who steals a phone or even somebody who's remote. So having all those controls in place are super important. And being able to test against those cases is just as important. MSTG has a great section called MSTG storage that really helps you kind of figure out those test cases and, works for both platforms. So in terms of changes in MASVS, we're looking at just a few changes that were added. A lot of them are more about the state in which data is on your device when. That's why I kind of said in the beginning, the best practice is know when your data is there for how long. And in this case, keeping data in memory instead of storing it on the device is a good practice. And checking what's stored in private storage or in public storage on the device if you're on Android is a good way to verify what's being stored. The other thing that's a really good practice is if your application has a user who fails to authenticate to it multiple times, it might be a good practice to just wipe the sensitive data off the device. That wouldn't be to say to wipe the entire device, but as a mobile app, you have control over what's stored on the private app folder or the public app folder that's in scope. And you might choose to just wipe that data after so many failed attempts, especially for highly sensitive apps. The other thing too that was added in this last year was encryption for sensitive data. And this one kind of seems like a no-brainer, but it is a challenge. Implementing encryption on mobile sounds like it's a simple thing, and it can be. The platforms have actually gotten really great. Back in the day, they were more complicated issues. There were issues with secure random. There were issues with how those cryptographic primitives could be generated and be stored and actually implemented correctly. And even though that stuff is out of the scope of data storage, when you're actually implementing encryption for sensitive data, those things kind of become part of that whole issue for data storage because encryption just makes sensitive data issues into key storage issues. The next one is really kind of controversial, I think, for a lot of people who come from the web world. And to tell somebody client-side security is important, they might scoff at you. And the thing with client-side security is on mobile, it's really important because a lot of the protections and a lot of the controls that need to be put into place have to happen on the client side. And I think the perfect example is network security, because a lot of you come from the the web world, and browsers typically will handle a lot of the handshake issues, whether it's hostname verification or accepting of self-signed certs. You get that big red triangle and you think, oh, I can't go on this website. I'll go to a different website. That's not the website I want to be on. On mobile, it is not something that happens by default. It's actually something that needs to be coded in by the developer. And then the error handling has to actually handle that correctly. Other things that come into play, and I kind of touched on this, was encryption. Encryption is really important. And mobile really gives you a lot of controls, hardware-backed storage, to really implement encryption in a really sophisticated way. And those controls all have to happen client-side. And finally, build settings. And build settings might sound silly, but build settings are really important because they can really prevent a lot of basic attacks. And build settings let you kind of optimize the app to leverage the platform controls. And if you really want to take advantage of all the controls that are in iOS 11 or, Android 11 and iOS 14, you're going to really have to use those build settings. And I can tell you that if you're planning on publishing apps in the future, those build settings are going to increase. They're going to be things that you thought shouldn't have been required in the previous version are going to be required for next year. So be aware of those things. Some of them are like scope storage. Some of them are like app signing keys and schema versions. And it's good to be aware of those things. And we'll talk a little bit about that later. So a lot of people ask me, well, you mentioned testing network on mobile. And really, to me, this is almost the most important part in mobile app testing to some degree, because a lot of the information you're going to get during this testing is going to help you out later on. And in mobile, a lot of what you're actually testing is the error handling. You're actually testing to see if the validations are being performed, if they react correctly and they error in the right way you expect them to. Because if you're being man in the middle, you really hope that the application will make the user aware or will respond in the way that it doesn't fail up and it only fails down. In terms of proxies you should use, it's really up to you. There's a lot of great ones out there, and I'm not going to say any of their names. But with that in mind, MSTG has a really great methodology page on how to do this, kind of taking on, there's different types of man-in-the-middle attacks that are of different severities. And then even after that, if your app is perfect and does something like certificate pinning, you're still going to want to bypass those controls because you're going to want to see what's actually in the TLS tunnel. And again, following those MASVS requirements, make sure that HTTPS is implemented on all requests. But not only that, that it's implemented correctly. And for certificate pinning, if you think your app may need that, you should work with developers and figure out if the case is helpful for your application, because it is a challenge to implement, and you should be aware of that. So many of you probably thought network testing, and you thought, well, are you talking about session management, authentication? What are you getting at? And in this next bullet point, really, for mobile, bad web auth is bad mobile auth is really speaking to the fact that the issues in one are pretty much the same as the other. One thing I've noticed a lot of in mobile testing is that a lot of the issues on web are common in mobile. And it's been my opinion that a lot of mobile authentication tends to get watered down or gets to be implemented in a way that worked for web but didn't work for mobile, or doesn't really work for mobile because the logic isn't there. There's new controls in place. There's other things that can be done in mobile that kind of make mobile a little more complex. But with that said, a lot of the really common issues in web are still in mobile. So rate limiting issues, authorization issues, logic flaws, lack of timeouts. Those are all really common things to see in mobile applications. And in terms of complexity, I mentioned network testing. And in network testing, a lot of it is seeing if those controls are in place. But when you're talking about looking at the authentication and session management in a mobile application, especially if you're doing gray box, black box testing, you have to bypass those controls if network security is being done correctly. So not only do you have to bypass them, then you have to make sure that, how does biometric behave differently to log in than the normal flow? Is there local auth in an application? Multi-factor is another thing. How is multi-factor implemented and how is it performed? And is the logic the same as what you would see on the website? And more often than not, it's hard to say. It's a mixed bag. So when we start looking at the changes in MASVS, we really see that the authorization models that are expected, you can have stateful, you can have stateless session management. But the most important thing to really keep in mind is that everything has to be handled server-side. So I know you're probably laughing. Didn't you just say like client-side security matters? Yes, but server-side security matters still too. Both of them matter. Server-side security is super important for this authentication and session management stuff. And it actually has a couple of line items in the standard for making sure that stuff is remotely enforced. So making sure that that stuff is remotely enforced is super necessary. Another area of interest for a lot of people is the reverse engineering resilience that people can build into applications. And the one thing I'll tell you is that a lot of these controls are great, but they don't compensate for the security controls you have in your app. So reverse engineering controls are kind of broad. There's some that prevent you from tampering the app. There's some that are built that if somebody does try to reverse engineer the app, it's difficult to interpret the logic. There's some that are built specifically for device binding. So, if you want to use your device as a token, as one of the MFA requirements, reverse engineering resilience can help with that. If you're an application that really finds it necessary to not only protect the information in the TLS tunnel, but your user's privacy, payload encryption makes sense. Maybe you don't want to know what's being sent from and by your users. So, payload encryption might be something that solves that for a lot of messaging apps where privacy is a concern. And those are all really important controls, but they have to be brought in after the security controls have been verified. So, it's tempting to say, oh, I'll just put root detection and that'll fix all these issues, or I'll use this, or I'll use MDM, or I'll do this. And, those are controls that are great, but they're not going to fix vulnerabilities. Those vulnerabilities are still going to be there. And if you're going to be testing mobile apps with developers, you're going to want to make sure that you're testing the security controls before you're testing those reverse engineering resiliences. With that said, you absolutely 100% have to test those reverse engineering controls. They take a lot of experience, a lot of skill. It takes a lot of know-how to do that. And it's challenging because what you're really trying to do is bypass things that have been built for you to not bypass them. They're built to, stop your tools, your open source tools, or other things that people are building to do exactly what, you really need to do to understand the app. So that does take a lot of work. And to some degree, it is a cat and mouse game. These tools are being outdated, updated, changed all the time. And it's kind of like left, right, going after each other all the time. So being able to, be aware of that, making sure that your security controls in place, then testing those resiliencies and making sure that they're working and they're not simple is really important. So the next thing I'd recommend when you're starting out and trying to understand what you should be doing really is the thing that you should be doing even after you learn all this stuff. And it's kind of a never-ending goal is policy. Policy is, it is the horizon on the mountain. It is the goal and, kind of the final step to some degree. But it's also kind of the first step as well, because your applications need baselines, they need requirements, they need standards. And MASVS actually has a really good model for this. They call it the AppSec model. And the AppSec model breaks things up into 4 tiers. So we went through a bunch of those domains and we talked a little bit about their requirements. What's great is that every requirement I mentioned, not all of them are standard. Some of them are defense in depth. For instance, certificate pinning is a defense in depth requirement. And not only that, those resilience requirements don't always fit into every single application. So what the MASVS standard did was it kind of broke things up into 2 categories. I like to think of it as kind of a Punnett square. For those of you who took, junior high school biology, and you remember Mendel and the P's and, how those P's worked, and, you try to figure out the alleles. That's basically what the AppSec model is. You have applications that have standard security and defense in depth security, and then you have applications that have a reverse engineering resilience requirement. So your standard security app has to meet baselines. Your defense in depth app has to have a bunch of technology built in that really protects regulated data. Or you might be an app that really doesn't do a lot of complex regulatory things, but has a lot of sensitive IP. And of course, you could have apps that do both of those things. So building on that is a really great start to figuring out what you should be doing and what you should be prioritizing in terms of fixing, because it's a challenge. Everybody wants to know, how do I look compared to my competitors' apps? How do I look compared to these other industries? And this is a great start to kind of figure that out. The other thing on top of that, in terms of policy, is not to forget that you can't skip privacy anymore. And to kind of build on to that, privacy is now regulatory. Privacy isn't what it used to be. Now it's something that's required. And, there's different states that are adding their own privacy frameworks, different countries. I won't go into details. Most of you know these things, or if you're not, you can, Google one of those 4-letter acronyms. But in my opinion, the best approach to privacy is kind of just being aware of what application data your app consumes, kind of taking this approach that you have a whitelist, or you have a list of, pieces of data that you're expecting your app to consume or app to use. Because when you have that data, you've become the custodian of that data. You have responsibility over it. And that comes with a lot of responsibility. So teaching concepts like, principle of least privilege to developers really helps them understand, don't take everything. Because it is kind of a common thing I've seen developers do, that they'll collect more information than maybe they necessarily need. And they'll think, oh, if I need that later on, I'll have that so I can use that for some reason or another. And, maybe that's unnecessary. The other thing too is third-party SDKs really might be the bigger concern, because third-party SDKs kind of represent this other thing where you may not know what it's doing, or it may be doing things and collecting things that you're not aware of. And I like to kind of say it's the monster under the bed, because you're not always sure what it's going to do unless you test the app and actually see what it's doing. So be aware of that. It may not be your developer's fault. It may be the third-party SDK or library that they're relying on that's important for business continuity. That might be the problem. So building on to that idea of policy and privacy, I think it's important to consider that, all apps are different. There's all these different things that come into play, and there's really not an easy way to say there's only 4 requirements, or there's only 4 logical cases where you'd want to do this, because all apps have different business logic. They all have different uses. They all have change. And I'm not even talking about just different apps. I'm talking about the same app even. An app changes, it gets new features, new infrastructure, new regulations, new technology, and everything changes. Not only that, but I'm sure a bunch of you are thinking, well, maybe I'll just use a cross-platform framework and that will just simplify everything. And this might be startling to some of you, but cross-platform frameworks don't simplify security. You still have 2 apps. You still have an iOS app and an Android app, and they both have to be tested independently because they have different platforms, they have different requirements, and they have different issues. And don't let anybody lie to you, because they are 2 different things. Ultimately, you're going to want to make sure that whatever you're doing in terms of developing this priority and prescribing context to these issues all have to be done from behind a threat model. So as your organization matures, look into that. Figure out what matters in your app. Figure out what the business requirements are in your app, because that's really going to guide how you prioritize these things and how you choose where you fall in that quadrant, and how you then build on that quadrant in terms of things you think you also need to do, or things you may think aren't really in context for what you need to do. And number 10, probably the most unpopular opinion of all, you need to partner with developers. Starting off, developers, are relying on a lot of the same sources you are, and those sources aren't always useful. A lot of code is out there, a lot of it's being copy pasted, into applications, and it's not all secure. A friend of mine from a reputable university shared this statistic with me. And when I saw it, it really blew my mind, because I thought to myself, man, I look at Stack Overflow all the time, and oof, that's frightening. So my tip to you is to go out of your way to kind of build a relationship with these developers. The fact is that security is about really providing requirements. You're not building these things. Developers are building them. You have to work with them. You have to figure out what the mistakes are, because the tools you're using might, flag something as a false negative, or maybe a false positive, and mistakes happen. And really, a lot of good security code is error handling, and that kind of is a hard thing to handle. So you have to work with them. The other thing is, like I said, your policy is going to change. Guess what a big part of that policy changing is? The updates to the OS. And you know who's going to know a lot about the new features in the OS, the new requirements in the OS? Developers. So you really have to work with them to learn about these things, figure out what's going to prevent them from uploading an app to the App Store, because that might be a security requirement that might be easy for you to enable. It might just be a flag that you just have to set to true or false. And not only that, being aware of those things really helps you understand, oh, hey, this new feature actually helps us out with issue A, B, and C. And that kind of helps remediate some of those things. So being aware of those things and working with developers and kind of developing those standards with them, understanding their business logic cases, does help build a better organization. So that's my top 10. And one thing I'll tell you is that top 10 isn't in any particular order. Really, I think there are things here that are more important when starting out. Figuring out your policy and getting on the right path and working with developers are really crucial things if you're building a program. And understanding all these things in terms of how they work and how that attack surface should be handled is important as well. And I wouldn't say any of these things is more important than one another. It's just being aware of how they really matter in terms of your program. So if you're starting out, I hope you use this to kind of figure out where to go next. Again, I'm Tony. I hope this was helpful. And I'm going to hand this back off to Brian. Thank you.
All right, Tony, that was really awesome. So I'd like to bring together some summary recommendations as we enjoy a nice cold drinking beverage right now. So it's clear that mobile and web are different, and that there's a fantastic set of tools and infrastructure around the OWASP mobile program, and a lot of really great people that are out there to help you not only grow your skill sets, but also pick and choose tools and leverage them as you grow your skills for yourself and for your organization to really build out a strong mobile AppSec program. Take the time to learn. The dedication pays off, right? There is a huge shortage in mobile security analysts with real skills. So this is a great way to augment your skill set and help your company as well, and work your way up the career ladder if that's where you want to go. And if you're really interested in exploring complex, interesting things, this is a great technology stack to look at around mobile, especially when you get things like IoT connected devices. So tools. So very briefly, a couple of tool examples. So there's a lot of open source or cheap, easy to use tools out there. Frida and Radari, we talked about, our researchers have produced for you. A lot of use of burp and minim proxy for things over the network. We actually embed minim proxy in our tools. Lots of other tools out there. Some are iOS specific, some are Android specific. There's a nice repo that another security researcher posted of a whole lot of Android tools. They're not all still in the market, but the repo is kind of a good listing that you might want to go to as well. Now, when you think about choosing commercial tools, you really need to think about not just can I reverse the app, but what kind of tools do I have that really give me security test coverage? And so best in class today really has organizations using 4 kinds of testing. So it's a combination of static tests, dynamic tests, interactive tests, and API testing for those backends. And so there's tooling out there that does some of these things. There's one vendor that does all of these things. So you could put together a couple different tools to get all your test coverage, or you can use a single vendor. And so in terms of coverage, right, you want to make sure you're covering the code. You need to make sure you cover that data in motion challenge set. You need to make sure you cover data at rest and cover the back end. And the nice thing is that static, dynamic, interactive, and API kind of line up on this. So use these as you organize your testing checklist, but also use these to select the tools that you might want to use in your organization. Now, most organizations really need to get to some level of speed, repeatability, and velocity. And so what we find is whether you call it shift left or simply tooling integration into your tool chain, there are good ways to build security into your SDLC. So make sure you have the right policies in place, make sure you have people trained on the tools, use, secure coding best practices, right? If you're in the security side of the house, make sure you work with the development team to have good secure coding best practices in the first place and take advantage of that. Make sure you're scanning the repos. So there's SCA and SaaS tools that can scan your repos for custom and third-party code. When it comes to testing mobile, it's actually better to test the binary than the source code. Most of the web world is about testing source, and there's lots of reasons for that, and there's only a couple languages. When you get to mobile, there's lots of languages and development environments, but more importantly, because it's an executable running in the wild, you have to test the whole thing. If you test source, you don't get enough. So you want to test the binary, and that's why state of the art today is automated binary testing from companies like NowSecure and a few others out there. Now, if you have many different mobile apps, make sure you take advantage of threat modeling that Tony talked about and do your tiered risk strategy. And so those higher risk apps don't rely on automated tools. Make sure you're wrapping some pen testing in there along with your automated tools, right? So the automated tools are like a smoke test, much like you've automated functional testing tools. You can use automated security testing tools. Then for your higher risk applications, you still got to run that pen test, and everything we just taught you, you can apply to do that pen test yourself. And then finally, kind of monitor in production. Make sure you understand how the app is behaving in production. Make sure you're handling bug fix releases and change requests, because obviously those are places where you can inject basically new vulnerabilities that you hadn't seen before. The great thing now today is that automated tools and integration capabilities are light years from where they were 5 years ago or even 3 years ago. So take advantage of those as well. And there's a great mix for you in automation as well as expert pen testing. Tony shared the details on the MASVS and MSTG resources. I have a couple more for you. Tony's bashful, but I want to share. He's got some great cybrary classes. So good starter class here on mobile app security for you. We've got a guide to really understanding the entire OWASP mobile security project. You can click on that. If you're working hard with developers, you want to understand secure development coding practices, right? The MSTG and MASVS are focused really on security analysis and testing. If you want to know how to write secure code, we have some stuff on that. And then I had some stats at the beginning. Well, we made some infographics and other reference docs on the most frequently found vulnerabilities. And what that basically means is use our learning on where to look for the likely vulnerabilities and where you need to train your developers to write secure code as well from our top 5. We're also having a little fun ourselves. So we actually have a MASVS drink list. So our company kind of enjoys their share. We're not a bunch of drunks, but we like to have a good time. So the crew is pitched in, and we've got our top 10 drinks list. You can get that from the link here. Some of them you'll recognize. Some of them are a little strange. We hope you enjoy them should you like to mix your own cocktail at home. And with that, on behalf of Tony and myself, I'd like to thank you for joining us today. You can reach out to NowSecure for more information on any of these. Tony and I have provided our emails here. We welcome requests for further information. We recognize there isn't a live Q&A session, so hit us up on Twitter or email. We're active on Twitter, so we'll be looking for things. DM or public requests are fine. And take some time to visit NowSecure for some more help on your mobile AppSec journey. One last thing, a huge thanks to all of the people working on the OWASP mobile program, the MASVS and the MSTG. It's been a huge project over the years, and there's many new things to come. So if you have the time, get involved with the OWASP organization and the mobile project and contribute your own time in our working sessions. Thank you very much.